So today I'm going to talk about UVM support in Verilator and basically scaling to large commercial designs that you can do with Verilator today, or perhaps you might be able to do soon. Generally speaking, Verilator is kind of one outlier in that it's an open source tool that's being used very widely and very effectively in ASIC design today. I believe that we have some really good news to share, and of course, like there's still work in progress, kind of a status report talk, but it's full of kind of good things that are already going on, and hopefully, of course, next time we meet, we have even more good news to share. Starting with kind of a little bit of background for open source verification. So as a company, and Micro is doing work in different areas in FPGA and ASIC design, and there's of course different ways people approach verification. We actually, as a company, are quite involved with like newer methodologies like CocoaDB, using Python for verification, trying to innovate, in the workflow itself. But as it happens, the majority of the world is using more traditional methodologies like UVM. Especially for ASIC design, there's such a pool of talent, and there's so many designs and test benches that already exist that just use UVM. You can't just say, oh, we're going to neglect them and do our own thing. I believe that the right way to approach this is to both kind of try to boost the emerging methods as well as try to support whatever's out there, so that eventually we can converge to a more open source ecosystem where both the traditional kind of design community can participate, but all the software-driven innovations that are happening in places like CocoaDB can also be included, especially for teams that can afford to adopt a new methodology, for example, for new designs or for kind of applications that allow it. But basically, of course, this talk is more about UVM itself and how we're trying to support it for commercial endeavors. And of course, this has been talked about for a time. It's not a new topic, but it was always considered some kind of a moonshot endeavor, right? Like everyone says, yeah, we'd love to have UVM, but then everyone also says, yeah, but come on, like, how can we do that if there's years and years and years of development in the proprietary space and open source just like didn't do it? We believe that open source has this magical ability of iteratively getting towards an outcome, and as you go, it snowballs into something you didn't even expect. So that's kind of what I think we're achieving here. And so we kind of set out to add UVM to Verilator. And we knew it was a big endeavor. It wasn't supposed to just happen overnight. But since we have Chips Alliance, we have a lot of companies and people collaborating together. And we decided that pooling those resources might actually make it happen sometime down the road. We didn't really plan like, okay, it's going to be 2025 or any specific date. It was more like, if we start doing it, we'll get there eventually. And Western Digital has been definitely a very kind sponsor of much of this work, but that's the whole beauty of Chips Alliance. It's not that we just work with them. There's actually lots of other people we're collaborating with, both within and outside of Chips Alliance. And Verilator as a project is a great community-driven collaborative project that a lot of the developments are just happening even independently of this work and benefiting this work, and some of our work is benefiting other people, and it's kind of really nice in this way. One major milestone that we'd achieved some time ago was adding event-driven simulation into Verilator. So Verilator originally didn't do event-driven, and so people didn't consider it a good candidate for doing UVM because you needed that. And people thought, well, no, Verilator's just not for this. It's great, it's fast, it's widely used, but its field of applications is limited. Let's not try, right? And then we kind of looked at it and said, well, why not, right? Like it's just a feature. It's something you can add. It didn't do it before, but since it's already a good and widely recognized tool, that's a very good thing to build upon, right? Because you could think of building something new, but then you'd also have to get the brand recognition and all the plumbing in place to actually make it a functional simulator and so on. So we decided that sticking with an established framework like Verilator is a good idea, even though it required a major overhaul of how it was doing things to incorporate this. So yeah, of course, this is an enormous task, and we're not saying that we're there. But on the other hand, we believe that picking a more like iterative approach and trying to not look at it as a binary endeavor, like you have to do everything or nothing, but more like you have to get somewhere functional and productive to iterate from there. We believe it's feasible. I talked about this already in Paris. So in May, we had this event called RISC-V Week, and I gave this talk, which was pretty much this kind of State of the Union talk, knowing that the event-driven simulation capability is already there, right? So in May, the capability was there, but it wasn't yet mainlined into Verilator. We kind of knew we were going to make it. Like, it seemed like we were on a good track of mainlining this, so we weren't really afraid that this was not going to happen. We were collaborating with Wilson Snyder and others to kind of make sure that this is work that can be mainlined, but it wasn't yet, right? It was still a fork of Verilator that could do event-driven. And of course, at that point, we also knew there were like heaps and heaps of other things and issues and features that were there and needed to be added to Verilator to support UVM-style verification. But we also knew that we would probably be working with them in the future. So in May in Paris, we knew that some project work was coming our way to make it happen. So we could be optimistic about it. So let's see if our optimism was kind of warranted. Called this part of the presentation from Paris to Sunnyvale, because essentially we've traveled both in time and space to get here. So it's been half a year and it's been many kilometers, but it's the same piece of work. First up, between Paris and now, between Paris and Sunnyvale, we ended up mainlining this event-driven capability. And that was, of course, really important because it's a big change. It's a scheduler that we have to kind of optionally enable. And we've worked very hard on this with Wilson Snyder and Gezelor and other people, of course, too. And this kind of work kind of complemented each other and helped to achieve this. Verilator 5.0.2, I think, is the correct version that includes this feature. But generally speaking, it's there. You can just turn it on. I didn't put in the flag you have to use to have it. But generally speaking, it's a flag and it's optional. So like everyone that's afraid, oh no, this is going to break the way I use Verilator, it's not going to do that because it's entirely optional. So if you're not doing these kind of things, if you don't want event-driven, just keep using Verilator as it did. But if you do want to do event-driven simulations, there's a flag for you that just enables that kind of scheduling. So this was merged. And then, of course, this was the beginning. We knew that, well, UVM is one word, but it's actually like 1,000 different small things that you need to do to enable it. So we decided that we need to get on with it and do it. In order to see where we are, we started tracking progress. We started kind of, we have this dashboarding kind of bent in Chips Alliance. We have, dashboards for tracking like the progress of the FPGA tooling and system Verilog tooling and so on. So for this specific kind of endeavor, we also built a dashboard that's online. You can look it up at all times. And it has a bunch of tests. And of course, like this is not a complete coverage of all the things that we need to do, nor is it like very thorough in covering every little aspect. And of course, if you want to contribute, like bring your own use cases into the test framework, that's great. If you have designs that you see some features are not there in Verilator, but you'd like them to come to Verilator, one way to make that happen would be to add a test case that allows us to know that this is not working, right? We can kind of guess what's working, what's not working. We're kind of very familiar with the Verilator code base by now, but having a test case is really, really useful. But this dashboard has been, of course, coming from our direction, like the designs we were working with, the designs that we want to enable for our customers. And so we built it out, and we were kind of seeing it go green over time, which is a very fun thing to do. And let's go through some of the things that we managed to implement throughout the time from May until today. The first kind of thing that we needed to add was concurrent assertions. So of course, many of the features that I'll be showing here on the slides are implemented in Verilator to some extent, right? But we were missing various kind of corner cases or syntactic capabilities and so on. And note that when we're linking to pull requests here on the slides. It's actual pull requests to mainline Verilator, and most of them are already merged, or practically all of them are already merged. So this is work that's happening in mainline. Of course, we have our own forks, but we try to kind of converge them as soon as we can. So as an example, we had to add value sampling, some keywords that just weren't there, and thanks to this, we're passing that part of our test suite without a problem. Concurrent sessions had many different aspects, and we also added some keywords like, well, not, that's kind of simple, but also name properties. So on this kind of screen, you'll see that we're kind of having a name property called check, and then we're using it inside, another property. So these kind of little things is, of course, a lot of dabbling in the internals of Verilator and the syntactic kind of parsing of stuff. But generally speaking, there's a lot of little things like this that we have been adding throughout this half year. We'd also been adding new types. So basically, there's missing types, signal types, and one kind of big missing piece was wildcard associative arrays. That was kind of a bit tricky to implement, but it works now. There's stuff like arbitrary string concatenation that just didn't work. Again, just adding support. There's kind of examples on the right. I don't know if you can see them well in the slide, but generally speaking, of course, the slides will be shared, and you'll be able to look at the examples, and all of the code is public, right? So if you want details on what exactly was implemented and how, it's kind of, you can just look at the PRs. So I'll just go through these quickly. We've been adding new types like unpacked structs. I mean, unpacked structs kind of worked, but they actually just behaved like packed structs underneath without telling you. So to properly support them, we had to kind of, again, add proper support, not just a fallback kind of support. We improved support for classes where some rudimentary support was there, but generally speaking, there was quite a lot of issues we had to polish, and now it's much better. Of course, perhaps not rock solid, but definitely kind of good enough to get us closer to where we need to be. Then there's virtual interfaces. They weren't there, so they're there now. Again, pull request to add this, and an example to show you a little code snippet. Those code snippets, of course, are parts of the test suite, so you can also go to the test suite and see if those are passing. There's also class type resolution. So there are some built-in classes that the SD package provides, but Verilator kind of didn't allow you to use them properly. You couldn't actually instantiate a class that wasn't defined in this package that you're in. So you had some classes coming from other packages. It didn't just work. So now it does. So this little snippet kind of shows how this will work. That's one big one. So UVM is kind of based on parameterized classes, and just they weren't there. So we had to add it, and these features are implemented in a big PR here. So here's a list of the things we have to do. And yeah, again, there's quite a lot of stuff that's working. I'm sure there's more that we need to add, but signal strength specifiers. This is one where quite a bit of work will probably be needed in the future as well, because we have some support. That's why you say very basic signal strength support is added. It certainly doesn't cover all the use cases, but it's kind of satisfactory for the ones that we're working with today. And yeah, we added a bunch of features, but definitely we'll have to kind of rework the way Verilator evaluates this. Currently, we're just kind of overfitting, let's say, to the use cases that we have, but we will have to kind of work on this in the future. But yeah, as I said, like an incremental approach is something that you need to adopt in order to kind of make this even feasible. The UVM itself kind of uses some built-in classes that Verilator did not support. So again, just added them in this PR. We also needed to just add some kind of capabilities in terms just of the control flow. So in the for each loop, we had to kind of add the ability to iterate over a string as an example. So yeah, we added some keywords and again, reworked some of the internals, and now it seems to be working. And going towards the list of things that were implemented, just so that we kind of can get to summary, we added support for the with keyword, so that we can do more like Python-like programming and Lambda constructs, which is kind of nifty. And you can see an example there of the find with IA equals request. So this code kind of starts looking kind of Pythonic, which is good. And this didn't work in Verilator before. So it's also kind of necessary for UVM. And one big one that I think deserves kind of mention is the work we did with constraints. And this is definitely ongoing work that'll need much more focus. But so of course, the whole UVM stuff is based on the idea of constraint, randomized testing, and we had to basically greatly extend that capability. We decided to go with an existing solver or group of solvers to enable this, and we adopted an open source library called Crave, because we believed it actually had a lot of functionality that we needed. We didn't want to really kind of write this from scratch again. We decided to adopt this project. We had to get rid of a lot of the dependencies it had because it was dependent on Boost and other things, and Verilator maintainers didn't want to include that in the project as a dependency. But fortunately, it was easy to get rid of the stuff that we didn't need, and we just forked the project. It's kind of not very active anymore, so I think our fork will just be part of the CHIPS Alliance, and we'll kind of keep developing there. But generally speaking, the existence of the framework itself was very, very useful for us because we skipped a lot of development we'd have to do. And it's always good to reuse stuff. So yeah, we have this Crave library. We have another library that's kind of a sub library that it uses, also kind of cleaned up and forked and cleaned up dependencies and made sure that we can use it in CHIPS Alliance. So this was already quite a bunch of work, but of course there's much more work in this area. There's a lot that remains to be done, and there's a list here, and of course, it's not a complete list. It's more of a list before we get to a functional UVM test bench that we can actually run, right? Fortunately, we don't think that those things we list here are kind of an astronomical amount of work, right? We think that we should be able to do them within several months, let's say. And so hopefully the next time we meet in this kind of setting, I can tell you, okay, we can run UVM test benches, right? And this is the beginning, of course, because when we get there, there's going to be a next milestone with lots of other features that we need to add. But hopefully, collaboratively, we can get there. And we're very excited because we can see the light in the tunnel. We've covered a lot of ground. I've shown you a lot of features that we've added. We have this capability to do event-driven simulation, and I'll show in a second why it's exciting as well. So okay, a little add-on on top of the previous part where I believe this is important to say because those two aspects reinforce each other. We're also working with other clients to scale Verilator up to bigger designs, right? And of course, as you do verification, you kind of get to the point where you need to have support for those big designs so that you can actually run those big test benches. And Verilator, of course, scales pretty well. It's already a good framework, but some of our customers are running really, really huge designs, and they'd like to spawn them across numbers of cloud-based machines. And that's where you start seeing those limitations. And our work for other clients involves getting rid of those limitations, fixing bugs, eliminating kind of memory issues, just optimizing performance. And especially as you scale massively, as you go towards verification, which kind of requires you to run lots and lots and lots of tests, those kind of performance optimizations will be super important because they will decrease your cloud bills and just make it easier for people to replicate your stuff. So this is kind of very much connected to the UVM work. As an example, we've been working with reducing memory footprint, and on some designs that we've gotten from our customers, we've gone from 72 gigabytes to 59 gigabytes, which is a pretty good reduction. As you can see, this goes below the 64 gigabyte mark, so you can use a smaller cloud machine to run your workload, because of course, with 72, you'd have to take 128 gigabytes of RAM, but now it can go to a smaller machine. So this is the kind of work that we're doing to kind of find optimizations that have practical value for customers, right? Going beyond a certain mark that's important for them from the cost perspective or from the functionality perspective, from the time perspective. So yeah. Another type of optimization we're improving the runtime of the relation. As an example, we've managed to go down from 478 seconds to 249 seconds for relating those big designs. And these are production-grade designs. These are not kind of invented examples, that are easy for us. These are the biggest of the biggest RISC-V designs. You might guess which ones these are. And yeah, we're getting really good results. So we're pretty happy. And there's a number of features in Verilator that we're adding to like enable or disable features and just tweak those parameters to fit your needs, right? Okay, summarizing. I think this one is nice. So I woke up on Wednesday, and this was like a tweet that we found on the internet, and someone's actually using our event-driven Verilator capability to simulate a DDR3 model. And it turns out that they got a 14 times speed up. So yeah, 1400%, I guess I should say. That sounds better, on their model. And this is just going from Icarus Verilog to Verilator. And Verilator just couldn't do this before, but now it can. And I think that we'll start seeing this kind of massive improvements in various areas due to this work, which will kind of generate people's excitement that will enable us to go further and get to where we need to be with UVM. So yeah, I really love this shout out. It's very nicely and kindly written. Of course, it's not just our work, it's the Verilator community, but certainly we've had an important share in it, so we're happy to be kind of here. So this is really the end. 2023 targets, of course, get some UVM test benches running, work with Calyptria to actually get it supported in some aspect. We'll see, of course, how much work that is. Enable frameworks like RISC-V DV that would enable people to kind of use this in practice as well. And of course, if any of you think that it's useful for you, or you'd like us to speed up this work by being able to provide more resources to do this, just reach out, and we'll be very, very happy to talk to you. Yeah, so that's all I had.
Great, thank you so much.
Sorry? Sure, absolutely. Okay.
We are from Micron. We got to learn this from you.
Are there any questions from the audience here or virtually?
Thanks. Hi. So the performance looks pretty amazing. And one thing that I don't know the details about Verilator in depth, but I know that one of its strengths is cycle-based simulation versus event-driven. So how did you kind of like coalesce that whole so in terms of event scheduling, is it still cycle based, or maybe it's a technical detail we could discuss offline, but just curious about if you could mention something about that.
I think it's the best question. It's a question best asked to my team. But in general, what I can say here is that we've been looking at how implementing event-driven capabilities affects, like how it operates. For example, the speed. Originally, we implemented everything in a kind of silly way that kind of decreased the original strength of Verilator is that it's very fast, right? And so the initial implementation was just way slower than the original. It worked, it did the job, but you could kind of run event-driven, but the performance was horrible. And then we ended up, there's a few blog notes describing how we did that. We ended up using C++ coroutines to implement event-driven and did a lot of kind of tweaks and tricks to make it fast. And it turns out that it's actually almost as fast as the static scheduler, which kind of almost surprised us. Whether we're kind of keeping some of the properties of the simulation, like cycle accuracy, I'm not sure, but I assume that is a design goal, right? So I can kind of forward it to the team. But yeah, I mean, they're looking at how do we keep Verilator good at what it is, without compromising on those things, but at the same time add the new functionality. And this requires like constantly rethinking and rewriting the strategy. But the Paris talk focused actually on this a little bit more, where initially implemented in a dummy way, just that works, and then you find a good way to just for example, use new C++ language features. So part of the discussion was now the new version of Verilator will need people to have a newer C++ compiler to allow that, and that was a big discussion in the developer community. But we decided, it's worth it, right? The coroutines are there to make these things possible, so we should use them and just assume that we have to move forward. We can't just stay on a very legacy GCC and not have UVM.
I think that was exactly kind of the answer I was looking for, because event-driven is usually based on threads, but with coroutines, you can get a lot much more functionality faster. So thank you.
So I was wondering, is this addition only to Verilator? I know that you are involved also with UHDM and SureLog, to integrate SureLog and Variable that way. Is any of the additions done there, or is it just purely Verilator?
We're mostly focusing in Verilator on that particular work. That's kind of because, of course, long-term UHDM is front end that allows us to do some fancy stuff, not just in Verilator, but at the same time, the focus of our customers get it working soon, right? So we assume that this is also going to converge. I didn't put it in the slides because I had some other topics in mind as well, because people ask hey, can you also do VHDL, right? And the answer is, well, probably through UHDM, yes, it's work and it has to converge. So it's all a matter of priorities. But yes, we kind of want to bring this capability to converge this with UHDM, to ultimately converge with VHDL, because why not? It's just that you have, as a company, we look for commercial need, because without that, you're kind of you're blind. You're just doing something and you're thinking you're making progress, but perhaps you're just after the wrong thing. Whereas here we have real customers that are I need to run this. And that's a very good goal to have, because suddenly you kind of cut down your scope and you look at the stuff, you burn down list of what needs to be done. You have a test bench to kind of tick things off, and it's kind of pretty powerful. And also kind of good for the team working on the project to know what the scope is.
Yeah, I had one question. Thanks, Michael. In the things that you support, was multiple inheritance one of them, or is that something not necessary or not critical?
Unfortunately, I don't know, but it's very easy to kind of just answer these questions offline.
And I think we had one question from online, Mladen Sibijek, if I pronounced that right. You want to go ahead and...
Hello. Yes, so I wanted to ask about the performance that you said that you got some lower memory footprint and you got some shorter relation speed. What did you compare? So is it compared to Verilator 2 4.2 to 8 against 5 or something else?
We're comparing basically Verilator from right before making the changes to right after making them, right? So we're kind of 4 versus 5 is not really the right way to think about it. It's more like we took the master wherever it was at the time we started the project, and kind of we compared, forked, made some changes, looked at, okay, how much faster do we get? We might have gotten some accidental boost from some, comments that have been done in between, but generally speaking, it was a pretty fast-paced project. So I assume most of those time savings and so on was the things that we'd implemented. And of course, it's a whole other talk. What kind of things did we do to get that? But we're not comparing to, we're comparing to basically Verilator from right before we started to Verilator now. And I assume we're kind of one of the major groups focusing on this particular aspect right now, right? But it's an excellent question, and of course, again, we're running those CI-based kind of dashboards to be able to drill down, okay, why are we better now? So, yeah, definitely happy to answer if you have specific questions, like how do you compare against this version? That just probably needs just to be checked, but we're happy to do these kind of comparisons.
Well, thank you so much for the excellent talk, Mike. I really appreciate it. And it's great work, or great to see all the progress that's being done on this. So I really do appreciate it. Our